All right, so we're going to look at solving equations with variables on each side again. Because what we're going to do now here is we're going to look at the solving equations involving grouping symbols and solving equations that have special cases. So again, 2.4, solving equations with variables on each side. And this is basically part B. Before I get into doing an example, remember, we're still going to use those steps that we wrote down when we took the 2.4 part A notes, the beginning notes, where we're going to use our steps. And this is where we're going to start incorporating that first step, which is distribute, get rid of the parentheses first. Okay, so we're going to solve when we see grouping. So what we're going to do here, we see parentheses, we see this. We are going to now distribute. Okay, so let's distribute the 7 to everything in the parentheses. 7 times n is 7n, minus 7 times 1 is 7. Bring down our equal sign. We're going to distribute this -2. You got to make sure you pay attention to what sign the number is that we're distributing to everything in here. So -2 times 3 is -6. -2 times n is -2n. All right. This is what we have here. Now we look, are there any like terms on each side to combine? No, there is not. Now we want to move our variables and we want to try to make sure they stay positive. So if we look here, we have a positive 7n and -2n. So we're going to add 2n, add 2n. These go away. 7 plus 2 is 9n, minus 7 equals -6. We look here, the n's are on the left, so now we're going to move our constants to the right. So we're going to add 7. Those go away. Add 7, leaving us with 9n equals -6 plus 7 is -1. The n is not by itself yet, so now we're going to divide by 9. Divide by 9, leaving us with n equals 1 divided by 9 is not a whole number, so we're going to leave it as a fraction. So n equals -1/9. All right. So this is how we do this. We get rid of those grouping symbols first, and then we go from there. All right. So I want you to try. Whoops, sorry. So remember, get rid of grouping. Follow step by step, just like it says on the Jamboard. You know, solving algebraic equations is like peeling onions. You got to peel it back one layer at a time. One layer at a time. Don't try to rush through. It's the tortoise and the hare. It's okay if you're the tortoise and you go step by step. Make sure you gain an understanding. That's the biggest thing. So what I want you to do here is I want you to try this on your own. Get rid of your grouping symbols. Run through step by step. All right, so you should be pausing the video now so that you can try this on your own. So please pause your video now. All right, so when you solve this, you should have distributed through. And then in the end, you should have gotten 6 equals y, or y equals 6. This one actually turned out to be a whole number. Remember, you can always check to see if you did this correctly. You could take this 6 and plug it back into this y, plug it back into this y, then solve and make sure you have the same number on each side. So you always can check your solution after you finish. All right, so this is involving getting rid of those grouping symbols. The next thing is our special solutions. All right, sometimes we run into things where our equations don't necessarily work out to what we're looking for. Maybe the variables disappear and things just aren't looking right. So these are some special solutions. So if we look here, let's look at the green one first. All right, we see some distribution. So I got to distribute this 3 through. 3 times 6 is 18, plus 3 times 4 is 12y. Distribute this 6 through. 6 times 2 is 12y. 6 times 7 is 42. All right. No like terms to combine. Now let's move our variables. Well, if we look here, I'm not sure. Let me just subtract 12y from both sides. Well, 12y minus 12y, that's 0. So those go away, leaving me with 18 equals. Well, here again, 12y minus 12y, well, that's 0 again. So those go away as well, leaving me with just negative 42. Wait a second, Mr. Harris. What happened to my variables? I thought we're solving. This is why it's a special solution. The variables went away. Our y's all canceled each other out, leaving me with 18 equals negative 42. Well, this is not a true statement. 18 does not equal negative 42. At least on planet Earth, it doesn't. Right? So what this means here is there is no solution. And that's your answer. Your answer is no solution. Because there is nothing I can plug in to y. There is no value, no number I can plug into y that will give me a true statement. So if you run into a situation where the numbers on both sides do not equal to each other, so they're different, the answer is no solution, meaning there is no number we can plug into the variable y that will give us a correct statement. All right? So let's look at another one. So let's see, hey, there's grouping, so I got to distribute. Okay, so let me distribute this 5 through. So that leaves me with 7x plus 5x minus 5 equals nothing to distribute over here. All right. If we look, so I got rid of my grouping. Now I need to see, are there any like terms to combine? There are. I have this 7x and this 5x. 7 plus 5 is 12x minus 5 equals negative 5 plus 12x. No more grouping on one side of the equal sign. Now let's work on moving our variable. I got 12x's here, so let's subtract 12x from this side. We're going to subtract 12x from this side. 12 minus 12, well, that's 0. Those go away, leaving me with negative 5 equals. And this one's 12 minus 12, which is 0, so those go away as well, leaving me with negative 5 equals negative 5. Hey, that's a true statement. It looks very similar to the problem on the left, except for the one on the left, that was not a true statement. The one on the right, that is a true statement. So if you run into a true statement where the numbers on both sides of the equal sign are the same, this is infinitely many solutions. All right. That means any number you plug in to the value x, it will come out as a true statement. That's what that means. And I'm going to show you guys how this works after the video when we kind of talk a little bit here. Okay. So if you run into a non-true statement, a false statement, your answer is no solution. If you run into a statement that is a true statement, so this is true, this works, yes, ding, ding, then the answer is infinitely many. So these are our special solutions. You can have no solution, you can have infinitely many solutions, or what we've been working on, you can have one solution. All right? So what I would like you to do is I would like you to try these on your own. These are going to be, I'm going to give you a hint, they're going to be special solutions. One of them will be no solution, the other one will be infinitely many solutions. So if you could, please pause your video now, and I want you to try these two problems on your own. So you should be pausing the video now. All right, so the one on the left, you should have gotten negative 6 equals negative 4, which that's a false statement, so the answer is no solution. The one on the right, you should have gotten 16 equals 16, which is a true statement, so that means you have infinitely many solutions. Infinitely many. So remember, if it's a false statement, no solution. If it's a true statement, Infinitely many. That means you can plug in any number into those variables and it will work. No solution means you can plug in any number into here and it won't work. But then there's also still that one solution we can go through. All right. So that is our special solutions as well as solutions involving grouping. Remember, if there was something you're like, wait, that's confusing. Can we do another example? Yada, yada, yada. Make sure you ask, because I bet you if you have a question, somebody else has the same question.